This video is going to go over the concepts that we went over in lab that goes over ionic versus molecular compounds. First, you can compare, when we look at the ionic compound sodium chloride here, it has a really high melting point and a really high boiling point. Ionic compounds tend to exist as solids at room temperature with extremely high melting and boiling points. The molecular compound that's given here is hydrogen chloride, and you can see that it has a much lower melting point and boiling point in comparison. The other piece of lab that you did was you took water and you added a molecular compound. Now, I don't know what molecular compound you used, but a good example would be sugar. If we take some sugar and we dissolve it in water. So here I'm going to use my spoon and get some sugar out. I'm going to pour that sugar into the water like you see here. I'll stir it up. And then I'm going to insert the electrodes of my light bulb in, my conductivity apparatus. And I'm going to discover that molecular compounds like sugar do not light the light. Now, in a separate lab, I'm going to get the same beaker. I'm going to fill it with some pure water. And then I'm going to get my salt shaker and I'm going to pour some salt in. And I'm going to stir it up and let it dissolve. And I'm going to discover that when I insert the electrodes of my conductivity apparatus, that it does indeed light the light bulb. And I'm going to think that's pretty cool. And then I'm going to categorize the salt, which I accidentally erased here. Salt is an ionic compound and it conducts electricity, so we call it an electrolyte. Molecular compounds are usually non-electrolytes. We're going to learn second semester that there are a few exceptions to that. But most molecular compounds, when you dissolve them in water, do not conduct electricity, but ionic compounds do. So, some ionic compounds that are listed here: sodium chloride, calcium bromide, aluminum oxide, and zinc sulfate. And some molecular compounds: glucose, water, NH3, which is ammonia, HF, hydrogen fluoride, and PCl5, which is phosphorus pentachloride. We're going to look at the chemical composition of these compounds. So sodium, our first ionic compound, if we find that on the periodic table, that is here. And we'll go back. Calcium is here. Aluminum is in group 3, still a representative element. Zinc is a transition metal. We're going to circle that one here. So you'll notice that these are all metals. Now if we look at the other ones, chloride, chlorine is here on the periodic table. Br, bromine, is underneath chlorine on the periodic table. Oxygen is up here. Sulfur and oxygen we'll look at together. Oxygen we already saw. Sulfur is here below it. So these are all nonmetals. So ionic compounds tend to be a combination of a metal and a nonmetal. Molecular compounds, if we look at these, we have carbon, hydrogen, and oxygen. Carbon is here, hydrogen is over here, and oxygen is there. H2O is composed of hydrogen and oxygen, which are here and here. NH3 ammonia is comprised of nitrogen, which is here, and hydrogen, which is over there. Hydrogen fluoride, hydrogen we've looked at many times, and fluorine is here. PCl5, we see phosphorus below nitrogen here, and chlorine we've already looked at here. But the point of all this is that these are all nonmetals, and so molecular compounds tend to be composed of only nonmetals. So ionic compounds, number one, tend to be solids at room temperature. They have high melting points, they have high boiling points, and they are electrolytes, which means that when you dissolve them in water, they conduct electricity. They are also typically composed of one metal and one nonmetal, although there are exceptions to that. There are some ionic compounds that are only nonmetals if they have the ammonium ion in them. But for the most part, ionic compounds, they're always a cation and an anion. Typically the cation is a metal. Molecular compounds tend to have low boiling points and low melting points. They could be solids, liquids, or gases at room temperature, but if they are solids, they probably have a low melting point and a low boiling point. Much lower than ionic compounds. They also do not conduct electricity usually when dissolved in water. We'll see a few rare exceptions to that second semester. And when you look at their chemical composition, the elements that make up molecular compounds tend to be all nonmetals.